right. So how was the test?
Okay.
Okay.
I mean, I'd say the second to last problem was pretty challenging for me, but
Okay.
the rest of it was reasonable.
Okay. So what we'll do today is to this is what I call the rub salt on wound session, because the idea is we want to find out at least what the correct answer is, and also if you guys have any questions about but why is that the correct answer and not this? Okay. So we have we can have some discussion over that. Just like with most of my other classes, I just want to emphasize the grading standard is not based on voting. So it has nothing to do with the majority of the majority of the people got this answer wrong this way, and that should become the correct answer. Okay. All right. I was just kidding. Right.
You could have put it in the
One. And here's the app. Google Drive. So what I'll do is I'm going to make the exam document itself, accessible to you guys. So this way, I will just type the answer into the exam itself, and then you guys will have a copy of that automatically. So let's go to that particular drive.
It'll just be a link on Canvas that we go to access it.
Mm-hmm. So this is the cisp440. Either my drive is having some issues or something is going on. This looks a lot slower than it should be. But Canvas seems okay. So I don't know what the issue is. Nope, Canvas is a little bit slow too, but not as slow as Google Drive. And this is exam 1. So I'll do this part first. I'm going to do the share, and then put a link on the using announcement. I'll give you guys the link to it. So let me make it open first. Change, and we'll make it public so anyone can see it. Copy this link. Go back here. Make an announcement. So this way you guys have access to it. So actual exam 1, and here's the link. Save. There you go. So if you have a mobile device with you, can be a laptop, can be your phone or whatever, you should see that announcement. You will get an email on these announcements too, so you can click on that link when you do get one. Right. So the document is shared. Click OK, and I should see a few animals, showing up here very shortly. That's usually the case, unless you guys sign in first, then we'll actually see the person's name.
Oh, animals.
Oh, there you go.
So exciting.
That is a hyena. Okay, doesn't look like a hyena to me, but that's what it says. All right, so let's go ahead and get started with these questions, starting with question number 1. And I think it might be helpful to make it a little bit larger, but not too large because I still need enough area to show the question text itself. All right, so you have to read the questions carefully. In this case, I'm telling you that f is a function already. I'm telling you f is a function, and this notation with a d and then a right arrow e is basically saying d is the domain and e is the codomain. So we have a function, we have the domain identified as the set d, we have the codomain identified as the set e. If we want to answer the questions in terms of injectiveness, surjectiveness, and bijectiveness, explain each answer connecting your answer logically to the related properties. An absence of property is not an indication of the negation of the property. In other words, if you don't tell me it is injective, it doesn't make it not injective. If it is not injective, you have to tell me it is not injective. Okay, I'm hoping that people will understand what I mean by that. All right, so if I tell you that the cardinality of D is greater than the cardinality of E, what can you conclude for certain, and why can you make that conclusion? What do you think?
Not injective.
Cannot be injected.
Cannot be injective. Very good. Okay, so we know that this is not injective. Can we say anything about surjectiveness?
It can be subjective, right?
It can be either way. In other words, whether it's surjective or not cannot be concluded for certain. Okay, so the only thing we can conclude for certain is not injective. And why is that the case? So here is where I need an explanation. If you can use the mathematical notation, great. If you cannot, using English is fine as well. Okay? So how would you explain that? Yes?
So because it is a function, you know that everything in D will map to E, like all the elements.
Yep.
And so two elements in D will have to map to the same element in E, which makes it non-injective.
At least two elements of D have to map to the same thing in E because there are more elements in D than there are elements in E. So that's kind of okay, as an explanation. I'll give full points to that, okay? But what would be the proper proof to this one if you were to ask a mathematician? Yep.
Like using that notation, you'd say of all the elements in D, there exists an element that.
Well, the notations, will help you understand what it means to be injective, but it doesn't really help answer the question, why do you know for sure that this particular function is not injective in this case? So the one way to prove it, okay, using a mathematical proof, is to prove by contradiction, which basically means, let's say that the function is injective. Let's see what's going to happen, okay? But if the function is injective, you will find out that it will lead to a contradiction. In other words, eventually something, will have to, on one side it says it's 1-to-1 as a mapping, and then on the other side it will say, no, it's not 1-to-1, and we'll get to a contradiction. So in this case, we can just say that there are more elements in the domain than in the codomain. But since every element in D has to map to one element in E, at least two elements in D map to the same element in E, therefore F is not injective. So the key part here is to identify that at least two elements in D will have to map to the same thing in E. That is the key. So put a boldface around this one, because that really is the most crucial part of the argument, is that. Okay. Are there any questions about part one of question number one? Okay. What about this one? What if I know the codomain is great, the cardinality of the codomain is greater than the cardinality of the domain itself?
It can be injective.
It cannot be surjective,
Yeah.
okay? Not surjective, okay? That's because each element in D can only map to one and only one element in E. Since E has more elements, some elements in E are not mapped from D. As a result, the function is not surjective. There we go. So you have to tie everything back to the definition of what is surjective. Surjective means everything in the codomain are used. But in this case, we're guaranteed that some elements in the codomain cannot be mapped, simply because there are fewer elements in the domain than there are elements in the codomain. And it has to be a one and only one mapping. In other words, one element in D has to map to one and only one element in the codomain. So that's why when you have fewer elements in D than you have in E, then the function is guaranteed not to be surjective. Is that okay? All right. How about this one? What if D, the cardinality of D and E are exactly the same? What can you conclude for certain?
Bijective.
No, you cannot guarantee anything. Okay?
Can be, but.
Can be, but I'm asking what can you conclude for certain? So nothing can be concluded for certain. And I think the next one is the same. Am I? Yep, they're the same. Yep.
You can conclude the cardinalities are equal.
Well, but that's given to you.
Same.
That is given to you, so that doesn't. I mean, you can certainly put it here in the answer. I would not count it wrong, but there's nothing. But nothing can really be concluded here. So, since the question did not ask you for, well, it did ask you for why. So, does anyone explain anything here that it cannot be concluded for certain? You can use examples, okay? So if you want to show that it cannot be something, you can use a counter example to show that, okay, look at this one, it is not injective. Look at this one, it's not surjective. Yep.
Well, 3 elements and basically D can map to the same element in E, right?
Yep.
Which makes it non-injective. And
Actually,
also-
okay, I kind of take it back. There is one thing that we know for certain. Okay? There's one combination that we know cannot possibly happen.
Of surjective and not injective?
Okay. It cannot be only not injective. Okay, I'm going to put quotes around the whole thing. Okay. Let me see if this makes sense. Or only not surjective. Or to spell out exactly what I mean by this, I would say it cannot be not injective, but surjective, or not surjective, but injective. Okay, this I know for certain. When you were doing your homework assignment, you should have encountered exactly this case, because I was asking you to make an example out of your, I think 3 elements in the domain and 3 elements in the codomain, and you should realize that these 2 combinations were not possible. So there is an answer to this one. It is not just inconclusive, that we cannot conclude anything. We can conclude that it cannot be one of these 2. Is that okay? When I explain the homework assignment answer, I have already explained why that is the case. Because when you have it being surjective, it has to be injective as well. When you say it is injective, it has to be surjective as well, because the domain and the codomain have exactly the same number of elements in this case. Is that making any sense?
Could be what we could have said, if it's surjective, then it is injective, and if it's injective, then it is surjective.
Aha,
Yeah,
okay.
it's not confusing.
Okay. Okay, the conclusion can also be stated as, okay, F is injective if and only if it is surjective. Yep, because one implies the other and the other implies the other one.
Yeah, that's what I was
So,
confused.
well, you can use either one of these statements. You can do the kind of longer way to say that, you cannot have only one of them, or you can say one implies the other and the other one implies the first one. Or something to the same effect. Yep.
Because I think on mine I did more of the last part, the F is injective, but
Mhm.
and surjective. So as long as you don't state that it's one and not the other, then it works kind of. You can't say it's injective unless you also say that it's
Yep,
surjective.
exactly. Yep.
Okay, that's
Yep.
what I was. Yeah. That makes
Yep.
more
And
sense.
I think part 4 is a duplicate of the third one.
No, it said not equal.
Oh. How come it doesn't show the not
It
equal?
does
Yeah.
on the shared document, it does.
Maybe you said like refreshed or
Okay,
something.
no. This is a Firefox issue. I'm gonna use Chrome.
Maybe if you change the font? I don't know.
No,
Yeah.
it's a browser issue.
Oh,
Well,
it does it in
it's
every
a
font?
browser
I remember
issue
being not equal in
and
the
also
exam.
interaction with the font I have installed.
Oh.
So it's both.
Yeah, I remember being not equal in the exam.
Yeah, that would be kind of like, I would
I think we
really
would
try to check that.
we would have questioned that during the exam.
Okay, so
Like
that's-
trick question.
Yeah, that would make it very tricky. Depending on the browser, you get a different.
Good thing it's not taken online.
Okay, so let's check that. I use Firefox most of the time because Firefox is just has more plugins, especially AdBlock.
Watch out, they're all gonna go away on Firefox 57. They're completely getting rid of all their old APIs.
But there's a new API, right?
Yeah, web extensions, but they're terrible.
Oh.
They're based on Google Chrome's extensions.
Oh yeah.
Okay, so it is looking right now. Okay, so for part 4, if the cardinality of D does not equal to the cardinality of E, what can we conclude for certain? Well, based on the answer to number 3, we know one thing is for sure. It cannot be both injective and surjective. We don't know which one it is, right? Okay, so the, the conclusion to this one is implied by either question number 3 itself or question number 1 and 2. Because not equal to is the same thing as greater than or less than. Which means you can refer to number 4. If you're lazy, like I am, you can say this is the conclusion. Oops, let me scroll up because people in the back may not be able to see it. The conclusion of part 1 or the conclusion of part 2. If you run out of time, this is how I would put it. Okay? Because it is true, okay? Because when A does not equal to B, what does it mean? It means A is greater than B or A is less than B. Does that make any sense? But that's exactly what A and 2, one and part 1 and part 2 are really about. One is saying, the cardinality of D is less than. The other one is saying the cardinality of D is greater than. This is just saying that it is that or 1 or 2. So if you run out of time, this is fine. Is that okay? But the conclusion, you can also say, okay, F cannot be bijective because it is either not injective or it is not surjective. So it cannot be bijective. Is that okay?
Yeah.
That we know for certain, okay? It cannot be bijective. It is either not injective or it is not surjective. Is that okay? All right? Okay. Moving on to question number 2. Given that function f, now this one is an interesting question too. So the question is saying,
I did not know what you were asking. I was so confused.
Okay, so let's read the question carefully and see if we can decipher the question. So given that function f is mapping the set 1, 2, 3 as domain to the set of ABC as codomain, and function g is mapping basically 1, 2, 3 to ABC as well. Okay, so they're both functions. They're both having the same domain and the same codomain. But the exact mapping is not given to you. I did not say what is f of 1, I did not say what is g of 2, and so on. But I'm also telling you in boldface that both are bijective. Now there are many ways to make a function f that is bijective with the same domain and the same codomain, and also for g. I just tell you one thing for sure, okay? I'm also telling you that f minus g, which are the elements that are in f but not in g, are as follows, okay? 1A is in F but not in G. 2B is in F but not in G. Well, I have just confirmed two things that are really helpful to answer this question, right? What has to be in F? Everything in F minus G has to be in F. Okay, let's start with that then. Do you see how this is giving you a good portion of the answer of this part already? But since we also know that F is bijective, which that means well, the third element can only be, since it's bijective. Now we know this has to be 3 because we know that every element in D has to be mapped to one and only one thing in the codomain. So we know the third tuple in this set, or the missing tuple I should say, because everything in the set is not ordered. But we know the missing tuple has to start with a 3 because that's the only missing element in the domain that has not been mentioned yet. But since it's also bijective, it means it is injective and it is also surjective. Well, if it is surjective, it means A, B are used already. C is the only one that is not used at this time. So that means the third element, or the missing element, has to map 3 to a C. Is that okay? All right. Now, when we look at G, okay, so we know that G does not have 1A, it does not have 2B, and we also know that it cannot have 3C. Well, it must have 3C because otherwise it's going to be there. So we know 3C has to be there because otherwise 3C will show up as part of the difference as well. Is that making any sense? Okay. So, but it is also injective and surjective, which means, well, the only way to do this, there's only one way, and it has to be like this. There's no other way to do it. So based on the constraints, this is the only way to assign elements to F and G. Is that, yep?
Could you re-explain that? I did that on it, but I'm still a little confused of why it makes sense, I guess.
Okay, you mean for G?
Yeah, for for F and G, like how it, why that mapping works, I guess.
Okay, so let me put down the explanation here. Okay, so I can make this look nice, but that would take some time. Okay, F has to contain. Okay, how about this? How about I use this notation
1A
here?
and 2B.
F minus G subset EQ. Okay, can everybody buy this one? Okay, it doesn't matter whether F and G are functions or not. If you look at F as a set, G as a set, everything in F that is not in G, that particular set, has to be a subset. It may not be a proper subset, but it has to be a subset of F itself.
Yeah.
Does that make sense?
Mm-hmm.
Okay, so if that makes sense, this means I'm just gonna copy and paste a little bit here. Well, I'll copy the whole thing and change this to superset EQ. Nope, there's no such thing. Okay, we can do this. Would you buy this? Right? So that means we know that 1A, 2B are elements in F already. It's missing one element because we know the cardinality of a function has to be exactly the same as the cardinality of its domain. Okay? What is missing is mapping 3 to something. So we know the missing tuple has to start with 3. But since it is also known to be bijective, that means it has to map to the only one thing in the codomain that is currently not mapped, which is element C. So is that
Yes, that makes
sufficient?
perfect sense.
Okay.
Thank you.
Mm-hmm. So when we get to G, okay, so the constraint of G is it cannot contain anything in F minus G. Is that making any sense? Okay. So that means 1a and 2b cannot be a part of G. But we also know that 3c cannot be part of the difference too, because if it were part of the difference, then it would have shown up in F minus G. So we know, that's why we know 3c has to be an element of G. Is that okay? But since 3c is an element of G, and G is known to be bijective as well, so we know that 1 has to map to B, because if 1 maps to A, then it won't show up as F minus G already earlier. So we know that F1 has to map to B, and 2 has to map to A. So I'm just verbally explaining it, but I'm hoping the logic is okay. Is that okay or not okay? Sort of. I see some nodding and then some frowning. So. Okay. So we can get back to this one. I'll let it soak a little bit. Okay. And because I moved around the pages a little bit, that's why it's. Oops. Q. There we go. Okay. So this is question number 3. And question number 3 is yet another way of asking questions related to functions. So this one is assuming F is a set that has the elements x1, y2, and z3, which is a subset of x times y. Okay, that's all I'm telling you. Did I say anything about F is a function as the first part of the question? Nope, I did not say anything about F being a function. Okay, F is nothing more than a set of 3 tuples. Okay, did I mention anything about the content of X? I did not. The only thing we can conclude up to this point is that X has to contain the elements of lowercase x, y, z, and Y has to contain the elements of 1, 2, and 3 because of the Cartesian product and the subset. Is that part making any sense? But did I say anything about X having additional elements? It may not. Okay, it's open at this point. And same thing with Y. It can have 1, 2, 3, and additional elements. Yep.
Wait, you said X can have additional elements, but that wouldn't be a function.
I didn't say it's a function. At this point, it is only a set of 3 tuples.
That's true.
Okay.
Right.
All right. Okay. So here come the questions. Okay. Part 1 is to say somehow define this X so that F is not even a function. Define X and Y so that F is not a function using X as a domain and Y as a codomain. But you cannot change the definition of F. You can change the definitions of X and Y. Well, this one is just lowercase x, y, z, and then just add something to it. You can say Miata. It doesn't matter. It really does not matter. Okay? You can say tack. You can say garage. Okay? You can even say 1. Okay? There's nothing that says that 1 cannot be a part of X. It just has to be something other than X, Y, and Z. Okay? If you don't want to think about this and your mind is completely blank,
There you go.
put blank there. Because you can't have an empty set as an element of another set. It's perfectly okay. Okay? You just need something other than X, Y, Z. That's all you need. Because now that X has 4 elements, okay, and your supposedly function F only has 3 elements, then F cannot be a function anymore because it is not mapping everything in the domain to exactly one and only one thing in the codomain. Something is not mapped anymore. Is that okay? But don't forget the definition of Y. You still have to tell me what you can assign in Y to make F not a function. But this time, that's fine. Y can be exactly 1, 2, and 3. It will still be fine. Not a problem. Is that okay? All right? Okay, second question. Define X and Y so that F is a function, but it is injective but not surjective. Yep.
if you had 4 elements and y as well, it would still not be a function, right?
Yeah, so y can be, so you can, if you really want to, you can say union or cup with some other set. Whatever it is, it's fine, okay? But y has to contain at least 1, 2, and 3. Yep. Okay, so in this case,
But isn't f a function?
yeah. What?
Right, we have f equals
Whoa,
the
whoa, whoa,
set.
whoa. Read the question,
Yeah.
question carefully.
There, f is not a function.
I don't
So-
want f to be a function with x as a domain and y as a codomain.
Okay, but it says assuming f equals
Yes.
x1,
Yes.
y2, and z3. That's like the entire thing of f, right?
Yep.
So then, isn't that a bijective map? I'm so confused.
No, because in order for something to be a bijective function, you have to know what is the domain, what is the codomain. Just because it's mapping.
I mean, it's a function. It's a one-to-one.
No, it's not a function. It is a mapping. It is a subset of the Cartesian product of x and y. And each element is a 2-tuple. That's all we know at this point. That is all it's saying, is it is a set of 3 2-tuples. The first 2-tuple, or 1 2-tuple is x1, 1 2-tuple is y2, 1 2-tuple is z3. Did I say anything about f being a function? No. Did I say anything about the actual content of x? No. Did I say anything about the actual content of y?
The x is
No.
in the content of x. F equals x1, those 3 2-tuples. That is it. That's all f is, right?
That's all f is. F is a set of 3 elements. Each element is a 2-tuple. And I
Yeah,
spell out
consisting
those
of x, which is one of the elements of the tuples. It looks like a function to me.
If,
It can be, but it doesn't have to
It
be.
is a function.
no, if x is equal x, y, z, and then, y equals 1, 2, 3, then it would be a function, right? Because if x and y actually.
That is correct.
But
Well,
it's
if
not.
if uppercase x is exactly x lowercase x, y, and z, then we know f is a
Oh.
function. We just don't. Then
Because
it
it's
depends on
not-
y
okay,
to
I
define
understand.
what other properties is associated with this function. Yes.
Because you use the subset of symbol instead of proper subset, doesn't that mean it has the same cardinality as the cross product?
Nope. It says it can have the same cardinality as the cross product. Yep, because if it's subset without the equal, if it's a proper subset of, that means they cannot equal. There has to be something in the Cartesian product that is missing in this particular set. I just make it as general as possible and just say that, well, maybe the same, may not be the same. Yep. Go ahead, back there first, and then you.
So like, no matter what you set x as, you already said in the beginning that f equals this subset.
Yes.
So then changing defining these values for x and y is not going to change f. F will be that bijective function either way.
No. F is nothing more than a set of 3 2-tuples. Now, is it a function or not? Depends on what is the qualification of a function.
Yeah, but you already defined it. You already defined f, so it doesn't.
But I did not define x nor y.
Except you already said that f equals lowercase x, lowercase y, lowercase z. So therefore, you've said that lowercase x, lowercase y, lowercase z exist in x. X may contain other elements, y may contain other numbers, other elements, but you've already defined f at the top.
I did not define x here.
Not x, you defined f.
I defined f, but not x.
Yeah.
But
so
by
f
change.
is already defined, so you
Yes.
can't change it.
Yes.
By changing x and y.
I can change x and y.
You can add elements to x and y.
That's what changes.
It's not defined here. I'm not adding anything. I have not yet defined what is x and what is y. All I'm saying is this set here is known to be a subset of the Cartesian product of x, uppercase x, and uppercase y. That's all I'm saying. I did not spell out the content of uppercase x nor y.
Well, you said that those are part of x and y.
Yes. So that guarantees that certain things have to be in uppercase X and uppercase Y, but it does not say anything about what else X and Y may contain as sets. Okay, that was you good? Okay. Yep.
So why would it be only those 3 tuples? Is it just how you define that?
Yep, that's just
Okay.
given to you.
Okay.
Yep.
From understand. Okay, thank you.
Okay. So is that okay? Is part 1 okay? Shall we move on? Yeah, go ahead.
I just think maybe I felt like I was a little confused on what it means to be like a subset. Maybe that's what.
Okay.
You know.
Possible. Okay, so what is a subset? What is the definition of a subset? How do you define that X is a subset of Y? Or A is a subset of B? If A is a subset of B, then everything in A is also found in B. Okay, and you can spell that out in a variety of ways. You can say, B minus A minus B has to be an empty set. If A is a subset of B, okay, I'm going to use the whiteboard because all of this stuff is actually in the notes too, and we have talked about this a few times. If we say this, it implies A minus B is an empty set. There can be nothing there, okay? But remember, this is a one-way implication. Just because A minus B is an empty set does not make A a subset of B. They can be disjoint. The two sets just have no intersections whatsoever. Yeah, let me think. Nope, I take it back. It is actually this is going both ways. If everything in A can be found in B, then A is a subset of B. So are we doing okay so far, or not? Yep.
You said that it's a proper subset of a Cartesian product of X and Y, then we can conclude that F is not a function, right?
You mean take out the equal here?
Yeah, make it just a proper subset.
Nope, does not make any difference.
But then that means like F has not same, like it contains less elements of X, not everything is mapped from X, right?
But we are talking about, this is a subset of not X. Okay, so implicitly there's a pair of parentheses around this. So we are not talking about, F being a subset of X. It is a subset of the Cartesian product of X and Y. Now, so when you look at this, we know that the Cartesian product of X and Y has at least 9 elements. It must have x1, x2, x3, y1, y2, y3, and z1, z2, z3. We know those 9 elements must be in the Cartesian product of X and Y. It might have some other stuff, but it has to have those 9 elements to begin with. So if F is to be a function, it has to be a subset because F can only have 3 elements. And the Cartesian product has at least 9 elements. So in this case, I can turn that subset of to a proper subset of. It would not have changed any other meaning of the questions. Okay. All right. So looking at this one, what do you think? Define X and Y so that F is a function. Well, if F is to be a function, then we know X, Y, and Z can be the only elements in uppercase X because everything in the domain must be mapped by the function. So we know that it cannot have any additional elements in this case. Cannot have fewer elements, cannot have more elements. We want this to be injective, but not surjective. So that means, this can be 1, 2, 3, and then some additional one. So we can have 1, 2, 3, and then either A, empty set, or tag, miata, and so on. It doesn't matter. 4, okay. I'm thinking most people would put a 4 here. But it doesn't have to be. Okay. So this one is not possible. Okay, because I want to make F surjective but not injective. This is actually not possible. Okay, why is it not possible?
You have to decrease the number of elements.
Because, well, you're given two things. Yep. Okay, go ahead.
Me or?
Yeah.
Okay. The only way we could make that true is by adding something to the domain.
Mhm.
But we can't add to the domain because that would make it not a function because we already know what f is.
Or you have to change how f, change the elements of f. So
Yeah,
this
so
one is not
we
possible.
can't change f, right? F is
That is
defined.
correct. You cannot change f.
Can
Yep.
you help me understand the notation F arrow, and then X cross Y or F arrow something? Because I'm used to seeing F colon, like domain, and then arrow codomain. Do you know what I mean? So like in question 1, you said define X and Y.
Oh, okay, I see. So it's
Yeah.
a notational.
No, I don't. I want to
Yeah.
know what that. I don't understand because I'm used to, like that's what I'm used to is seeing F and then I see a colon.
Okay.
Okay, and then
You
I see
are
like.
correct. I did make a mistake in the notations
Oh.
in the test.
Okay.
Yep.
Well, then that completely.
F colon X arrow Y.
Yeah, this really should be X colon and X arrow Y.
Okay.
Yep.
That's a big difference. 'Cause
Yeah, so I will take that into consideration when I grade this one. If I ask who was confused by this one, I think the whole
Ooh,
class
I
is
get-
gonna raise their hand now.
It was kind of confusing.
But during the test, nobody asked me about this notation. It's like, we have never seen this notation before. What does it mean? Okay, well, that's okay. I'll make a note here. Okay, the notation of f being function mapping x to y was wrong. Okay, so that way, I remember to grade it, with that in mind. Yep.
Just for future exams,
Mhm.
whether or not it's explicitly mentioned in the instructions, is
Mhm.
not possible always a valid answer.
If it's not possible, it is. Then you always explain that. Yeah.
Because and I remember asking about this, that's
Right.
the thing that originally confused me,
Uh-huh.
is usually on previous homework assignments,
Mhm.
when not possible is a valid answer, you say not possible is a valid answer.
Right.
On this one, it's not mentioned, so I was a little confused whether or not
Yeah.
that was a valid thing to
Because
put
there was
down.
like one or two that
Understood.
that was
Okay,
not
so
possible.
in the future, mention impossible, please explain in all questions. So even when impossible is not actually a valid answer, I can still put it there.
You put it on the front page.
Yeah, put it on the front page. I think that would be the better way to do it. Okay, but we still have to finish this one. It cannot be surjective but not injective. Okay, so it's not possible. So we'll say here, let's say impossible because f has to be injective. Okay. What about the last one? Define x and y so that f is not surjective and not injective. Same answer, not possible because f has to be injective. Okay, so go to here. Right. So I'm gonna grade this one, with this in mind. Okay. What about question number 4? Question number 4 it's kind of like the reverse. Okay, so we know that H is a mapping like this, but we don't know how the G is defined. So the way you do it is to apply the inverse function first, and then you figure out, oh, okay, this one is here, that one is over there. So let's go ahead and apply the inverse function. So we'll do an insert equation, and then we'll do the inverse first. So we'll apply G inverse of the number, which is 428. And what does that turn out to be?
6 and 22, I believe.
6 and 22, 6 being first, and 22 being second? Okay. Well, we can always double check that. I mean, that's an easy thing to check.
This one's 6. Over 6.
We just need a new spreadsheet to do it. Okay, there we go. So we want to confirm whether it's just 6 and 22. So it's 6 plus 22, 6 plus 22 plus 1. The whole thing divided by 2, and then 22 is the y. And that turns out, formula parse error. What did I do wrong here?
Maybe put a multiplication.
Oh, yeah, it doesn't understand just that. Okay. Yep, okay, so this part is right. All right, so right away, what do we know for sure?
That the y value for the h of 1, 6, and 5 is in the x spot. So
Yep.
the setup is like g of x, comma, g of y and z, but we don't know g of y, comma, g of x and z, but we don't know the order of x and z yet.
Yep, okay, so we know that x, okay, we can use the exact number, 165. And by the way, there are two variants of this question, so if yours doesn't look like 165 to begin with, it's okay, there's one other version of this. Okay, so we know for sure that this one is, the 6 is the y, so this is the g of a 6 and g of something here. Okay. 6 goes here, so 6 of some question mark. Oops. Undo. Okay. Question mark, close, 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 close. There we go. Okay, so I got the question marks correctly done here. Okay, is that part okay? Okay, the whole class, yep.
Can you do, like, write out the functions that you use to provide on that number?
You mean the inverse?
Yeah.
Okay, so I can look it up.
Yeah. So
I mean,
I don't think I had the right formulas.
Ooh, that may not be good.
Yeah.
I didn't use it for some
Okay,
reason.
so that one is in Olive Knoll and kind of toward the end of it. So if you look up Olive Knoll and you look at so you have to first compute the W, and then once you have the W, which is this, then you apply okay, this is the closed form, final form here. So the inverse function is the W times W plus 3, the whole thing divided by 2 minus N is the X. So that would be the 6.
Right.
And then the other one would be the Y, which is the 22.
I figured out my problem.
Oh.
Is inside the floor function, I put a +1 instead of a -1.
Oh.
When I wrote it.
Oh.
Yeah.
You mean here?
No, on my notes. I did it.
Oh.
And I put it there.
Ouch. Did you write it down on the paper?
Oh, yeah.
On your exam?
No. Maybe.
Okay, because if you write it down on your exam paper, then I know that you know the general equation. You just made a mistake recalling the equation, so and then everything got wrong. Okay. All right. So now that we know this part, we'll do the inverse function on 22. So now we can say insert equation G inverse of 22, and that one is it 1 5 or 5 1? 5 times 6. It's a 5 1.
I think it was 5 1 there. So I could be wrong.
Okay. Well, we can test it.
I just remember the order being really weird.
Mm-hmm. Okay, so it's 5 1. Okay, so it's 6 times 7. Yep, so it's 5 1 for sure. Okay. So this one is 5 1. So from this we know. So we know everything that we need to know, because now we can actually make a conclusion and say this one is 5 1. Okay? So if you get to this point, if you just give me this much, you get at least most of the points for this question, because the question did ask okay, express it in x, y, and z. But when you do get to this point, then you already have identified the x, y, and z already. So this would be x, this is y, and this is z. Okay, so I'm gonna write it down here. Yep, go ahead.
With this question, is there more than one answer that is possible, or is it only just that only one combination?
I think there's only one answer possible.
Okay.
But so what did you get?
I think mine.
There are two versions of this question though.
I think I had this version, but I don't think I had the same order when I didn't use the inverse function to solve it. I just used the other function and just basically tried various combinations on scratch paper until it worked out. But I'm wondering if I did it wrong.
Okay. There was another hand earlier. Okay, well, I'm going to look at your actual answer.
Yeah.
And we need extra parentheses because we are talking about coordinates here, so that's why we need all the extra parentheses. All right. So is that okay so far with this one? Okay, all right. So this is one way to do it. The alternative is to brute force it. Is to try all the possible ways and then until you find it. Which is painful, really painful, because there are many ways to do it that way. We are talking about 3, choose 3, and times 2.
Mine seems like I'm the second attempting.
Huh? No, there are 12 possibilities. There are 12 possibilities. There are 12 possibilities because you got x, y, z, x, z, y, y, x, z, y, z, x, z, x, y, z, y, x. So that will give you 6, right? But which one you group first is the alternative. In other words, do you group it like this, or do you group it like this? They are different. So that's why each row gives you 2 possibilities. So there are 12 possibilities to test if you brute force it. Is that okay? All right.
Your answer still looks like that's a hint. So that the GXY is in the front. It's okay.
Yep. This one?
Yeah. I thought that this sentence means your answer should look like this somewhere.
It looks like this, meaning that it's going to be you're going to have a nested application of G with XY in it. Because you can also interpret this question as X, Y, Z is in this order, but G is nested differently. Yep.
So which one was the right? Is it that parenthesis X, Y, parenthesis, comma, Z? Is that the correct grouping?
Which one again? This is the correct grouping.
You did it, yeah.
Yeah. Yeah. So this is the correct grouping for this particular one, but there are 2 versions of this question. All right, I'm going to pass the row sheet today. Okay, so are we okay on question number 4? Okay. Let's move on to question number 5, which is the last one. Or is it? Nope. 6 questions. Okay, so assuming G is the same function as in question number 4, let P equals to G x naught y naught for some coordinate x naught y naught in the 2D space. Without evaluating the whole G function, I want you to express G of the G value of x naught, and then the y coordinate is just one more than the other one. Okay. In terms of, I want that to be expressed in terms of P, which is the G value of x naught y naught, x naught itself, and y naught itself. Additions and subtractions may be used, but not division or multiplication. You may introduce constants like 1, 2, and so on, and show your derivation step by step. So how do you do it? There are several ways to do it. You can either use a picture way to do it. The pictorial way of doing this is simply to explain, okay, and say that this is x naught y naught, x naught y naught, okay, and then you're looking at 1 pixel on top of that. So how do you get to the outer pixel? You have to finish the diagonal line, start the next diagonal line, and then plus 1 to get to it. So that's one way to look at it. But if you want to use algebra to solve this equation, you can do it too. So we'll use the algebra way of doing it because that's kind of like the surefire way of doing things. Okay? So with this, you look up the definition of the g function, and then you say, okay, this is the same thing as x naught. Okay, since I'm not gonna type, x naught, just type x. Is that okay? Because otherwise, it's just a whole lot more keystrokes for me. So this is x plus y plus 1 times x plus y plus 1 plus 1. Okay, because we're talking about y plus 1 being the y coordinate. Divide the whole thing by 2, and then plus y plus 1, 2. So we have a plus y plus 1. Is that part okay? I mean, let me magnify a little bit. Yep.
I mean, I thought you were being too specific, but when I thought of not division or multiplication, like, well, what can't be? What does that mean?
You cannot use division nor multiplication.
I don't understand what you mean by that.
Yeah, because I mean, how I see it is you're using division.
I'm not done yet.
Okay.
But I'm not done yet. I'm not. Okay, but I'm not done. Okay, so you take this, okay, and can we simplify this a little bit? Can we move things around a little bit here? Okay, so what I'll do is I'm gonna say, okay, let's group these two, and then we'll group these two too. Is that okay? All right, so assuming that's okay, we'll look at this one. And is it okay for me to group these two into that? All right. I'm doing this really step by step here. Oh, actually, I have a 1, and we group this entire thing, and there's another plus 1 here. I think. We'll just multiply the whole thing out. Okay, so we'll just go ahead and multiply the whole thing out. Well, I'm not done yet. Remember, I'm not done yet. Okay, so when you multiply this whole thing out, you get x plus y, the whole thing to the power of 2. That takes care of the x plus y times the x plus y. And then we have the 3 plus 3x plus y, right? And then we have a plus 2. Is that okay? If you look at x plus y as z, okay, it's just a quadratic equation. Is that okay? Yep.
Maybe I'm just missing something. Can you explain what the third line of the directions mean?
The third line of the direction. You mean here?
Yes.
So you can use addition and subtraction, but not division or multiplication.
What do you mean by the final answer?
Yeah, the final answer.
Yeah,
So you can when you derive it, you can use anything you need.
I'm so confused.
I felt like in a step-by-step process.
Damn.
Remove that line, everything becomes.
That would've made so much
clear.
easier.
Remove.
Just remove the sentence.
Or expand on it maybe.
Yeah. Okay. So actually, I got this part wrong. It's not. It is true, but it's not in the direction that I want. So I'm gonna change this a little bit. Ah. Okay. So getting rid of this. So we get x plus y plus 1 times x plus y plus x plus y plus 1 times 2. Would that be okay? I'm just distributing the second term over the first term. Yeah? Okay, so if this is okay, then we chop it into 2 fractions. Okay, so I'm going to put a, oops, not that. Okay, plus frac. Okay, so the second one is just taking care of 2 times x plus y plus 1 divided by 2. And because that is done on the other side, I can now take this away. Would that be okay? Sort of? Okay. So here's the magic. So I look at this term here, and can I do this? Would that be okay? Okay. And do we recognize anything here? Okay, so here's the part where I can say, isn't that gxy?
Yeah.
And on the second term, because we are multiplying by 2 and then dividing again, so can we re-express the second term as, okay, let me have to delete the right thing, paste again. Would that be okay?
Gotcha.
Okay. So we take this, and then because here, this is how we define P. So now this is P itself. X plus y plus 2. There we go. Is that okay or not? Yep.
I think it was just confusing, like, that when it says do not use multiplication or division, I thought, like, in any of your steps, not just in the final answer.
Oh.
That's what it seemed like, and then there's a whole lot of multiplication and division going on.
Yeah, I was confused by that too.
Okay. Yeah, because, well, okay.
Because that would have been so much
Without
easier.
evaluating the whole g function, express g of x naught, y naught plus 1 in terms of p, x naught, and y naught.
Period. End of thought.
It doesn't say in final answer.
Okay. So, okay, I see.
And then I just didn't even see where to go from there, like how to get that equation.
I couldn't even answer it.
But in that case, you can use the pictorial way.
That's what I was going for.
If I didn't know we could draw a picture.
Well, a picture does not have multiplication or division, right?
Oh my God.
But it doesn't say that you can.
No, but it doesn't say you cannot use it either. But the ultimate objective is to evaluate the g function of this new thing, express this in terms of p, x naught, and y naught. Yep.
What if we got to the answer without the derivation? Is that point worthy?
You got the answer to that?
Yes.
What's wrong with you?
So you have no explanation of how you got
found
there?
a pattern, like I took 2 arbitrary numbers,
Uh-huh.
the next number, pick the next. So it came out to be p plus x plus y plus 2.
Uh-huh.
So I just plugged that in as an answer.
So you just trial and error kind of thing.
Pretty much.
You basically try out several times and then you figure out the
Final
pattern.
example.
I tried that too, but I couldn't get it down.
Well, okay, so I can tell you, okay, so I guess the best way to do it is to see in the final answer you cannot use division or multiplication. Okay, yeah, go ahead.
Did you record?
Yeah, I think so. I'm still recording. Yep. Any particular concern?
No, I was a little late, so I actually missed that part.
Okay.
So I thought it didn't happen.
Okay. Yep, I'm still recording. But that is supposed to be the answer. And you can use algebra to help you, or you can use the pictorial way, or recognize the pattern.
Yeah, I have to go that way because of that.
Oh, because
Like,
of
no
not using multiplication and
don't
division?
evaluate g and all that stuff.
Okay. So maybe in the future, mention in the final answer. Okay. Put in quotes. Here we go. Okay, what about question number 6? Okay, so let's work on this. Yep, go ahead.
You showed us how to derive sigma notation from when I equals 0, but not when it equals an arbitrary number.
It is still an index. I is just an index in the loop. It starts with A and ends with B in this case.
But you didn't show us exactly how to like deal with I as a number in the final like sigma notation from one to the other, because the one that you showed us was with a 0. And I'm pretty sure that was factored out in the final.
Okay. Well, let's. Oh, so you're not understanding this notation itself.
Like, I figured out how to split the two and do a few things, but when it came to just evaluating I equals A to B of I, that was impossible for me, just because when you did it in class, you did it from 0 to B.
Okay, so what is this part okay? I mean, did you get this part?
Yeah.
And the last one is 1 plus B. Is that okay?
Yeah.
Okay. All right. Because that's what you need. Because once you know this, okay, we can now derive. Okay, so the idea is to get this back to the form that we know. Okay. So we say this is equals to, so we want to say minus A, put a minus A here, oops, and put a plus A here. Would that be okay? I'm changing the range, but I'm putting the plus A back so that even though the range is A less than, both the beginning and the end of the range is A less than what it used to be, but the term itself has A compensated. Yep.
We're just adding A to B is sigma, does that work as well? So we move the I equals 0. We have B plus A as the top.
B plus A. I think it has to be a minus, it cannot be a plus. But is this okay? Because all I'm doing is I'm adjusting the start of the range, the end of the range, and then each term has the plus A added to it. Yep.
So how do we know that that's legal? They can do that.
We didn't know the rules.
Because the way we did the homework, we did all the proofs, is to rearrange the sigma so that we can work it out.
We didn't get any homework on it, so it's like I understand that it's hard to have a certain direction.
You didn't know this was an option?
No. I mean, we were given. We didn't know if it. For example, we didn't know if we could use what was the aleph null or the inverse functions and stuff like that with the pixels. If we could have 4 of them, and so we were prepared if we could extend the amount of numbers that can be in a 4-dimensional or 5-dimensional. You know what I'm saying? Huh? Oh, because we were wondering that. Could we use a 4-dimension?
If you could give like a 4-dimension, and like
1 dimension.
Give me 1 pixel for 4 coordinates. So we were thinking like, can there be a question like that? So that's what he's saying. Like we were not thinking about this kind of a question.
Okay. Well, let me work out the entire answer first, and then we'll go ahead and talk about that part. This plus. Okay, so what I'm doing here is I'm just getting the 1 plus A out of here into the second term. Is that part okay? All right. Because I use this trick too, in the proofs that we talked about in class. This was one of the tricks that we talked about, is to split, a whatever expression that we are summing over, and just, we can split it like this. So then we take this and we go like, well, the first one we recognize. This one here. So the first term is a fraction of b minus a times b minus a plus 1, the whole thing divided by 2, because that is the one that we already recognize, which is a sigma notation from 0 to whatever number. Is that okay? Because we're just replacing n with b minus a. So now we have the second one to deal with. With the second one, we know that 1 plus a does not depend on I. In other words, we're just adding 1 plus a, which is a constant of some kind, b minus a plus 1 times. So now we say, okay, we can get rid of the sigma, and then just say this is b minus a plus 1, because that's the number of times we're adding 1 plus a. Yep.
Can you just separate the 1 and the I right at the beginning?
Yeah.
Yeah, that's what I did.
Yeah, you can separate it at any stage.
Right.
Okay, so if you see the constant here and go like, oh, that's just b minus a plus 1, you can break it out early on, or you can break it out late. Either way is fine. The key is a itself is a constant as well. It's just as much of a constant as 1, except you don't know what a is. A is going to be given to you. So at this point, you can do some simplifications, because you can see that b minus a plus 1 you can do some factoring. So you can multiply 2 of 1 plus a on top of this, or you can just leave it the way as it is now. They're both considered correct. Is that okay? So the only trick that I did not really show in class is how to slide the summation from using a to b as a range back down to 0 to b minus a as a range.
I was trying to figure out how to do that online. I just couldn't find, like Googling it, there's a lot of different terms in terms of summation, so there's so many results that I was just like,
yeah, because
I spent a couple hours looking for that.
Because ultimately what this really translates to is, if you look at the code, if you were to code this in C and C++, it's just asking, can we somehow change the range of the summation, but keep the sum itself the same? So if you have the first loop is for int I equals a, I is less than or equal to b plus plus I, and then we have int sum equals to 0, and then here we have sum equals to some kind of function. I don't even care what function it is. Well, actually I do need to know that. So this is sum plus equals to 1 plus I, which is the index here. So I'm taking this and I'm asking the question of, can we change this so that the range of the loop is altered? So we just do it minus a here, minus a, and then over here we have to do a plus a because we have to readjust so that it's still summing the same kind of terms. So if you can see that these two loops are identical in terms of the meaning, then it's translatable to answer the question. Is that okay or not?
How would you look up examples like this? So like to find more loops, you know what I'm saying? Like, 'cause I tried Googling like shifting, or I've used every.
Try evaluating sums or something like that.
Okay.
Yeah.
Well, okay, so
I'm just wondering if there's any like.
I understand what you're asking. So let me see if I can do this part here. So I'm just looking at this pattern here, and I'm just thinking, can we look at the spelled out version and use that to kind of figure out the other one? So you can see that every single term has, even the last term, has a 1 plus a in it.
Yeah.
Because you can always do that.
Right.
Right? So this way you can extract the 1 plus a out of the whole thing, which means the first term implicitly has a plus 0. So sort of, I'm not sure whether this is what you guys can see or not. So if you, once you get to this one, then you say, oh, okay, so I can see that each one starts with 1 plus a, which is a constant because a does not change. Oops, there we go. Can't type. And the last one is that. So from here, then you can see that we are, the only thing that is changing for each term is this one here. It goes from 0 to 1 to 2, all the way to b minus a. But the first part of each term, which is 1 plus a, does not change. So now it's a matter of counting how many things do we have here. But since we are starting from 0, so the number of 1 plus a is going to be b minus a plus 1. So that's why we have b minus a plus 1 times 1 plus a. And then on top of that, we have the usual summation of going from 0 to b minus a, I, and that would just be b minus a times b minus a plus 1, the whole thing divided by 2. So I guess this is the other way to look at it, so instead of sliding the sigma itself, you can kind of look at it and go like, okay, I can see that there are terms in each one that is constant, and just take those out by themselves. Yep.
The tough trick about this, at least for me, would be knowing that you can subtract a from the end and add it onto the front to make a consistent, to make a constant out of 1 plus a. Like, I would never think to do that. Just because we don't like working with sigma notation. For me, it's been semesters since.
It's a little bit new. Yeah.
It's like something I did a long time ago, and not that much even. So
okay.
It's hard. Like if we had more, maybe an assignment working with sigma notation or something, just like the exam.
What?
Was that pretty much Gauss's method?
Okay.
No, that's not Gauss's way of thinking about it.
Okay, well, noted. All right. So we only got about 4 minutes left. Yep.
Can you scroll up to the answer?
Hmm?
6.
Sorry?
Can you scroll it up a little?
Yeah. Mm-hmm.
When can we expect our graded exams?
When it's graded. So I'm going to start grading it, because this is a useful session, because if I were to use my original grading standard, I probably would have to go back, change it, and grade again. So I'm going to take the input of today's discussion into consideration, so that I can, when I establish the criteria and also the rubrics, it will reflect our discussion today. So typically what happens is, when I look at the final grade after I do all the grading, and I see that, hey, how come the best score of the entire class is 75, then I usually just kind of scale it, so to the point where the proportions of A, B, C, D, F, would seem reasonable to me. Typically, maybe close to half of the class getting B's or better. That's usually what I consider to be a correct normal term. Yep.
And for your tests, do you consider like 62% up of B?
Yeah.
And, okay, so use the same.
Yeah, it's the same scale for the entire semester for everything that I do.
Okay.
Yep. So that means to get a C out of this test is 37.5%. So that still applies. Yep.
And how many more exams do we have?
We have exam 2 and a final exam.
Oh.
So exam 2 is 20% and final exam is 40%.
Is final cumulative?
Huh? The final is sort of cumulative with a heavy focus on the later material. All right, stop streaming.